Hi students, we are going to learn one more derivation that is related to regression. So in the topic regression coefficient, derivation of regression coefficient, we are having two coefficients, one is y on x and other is x on y. So today we are going to learn about y on x. So this is very important related to unit 1 semester 3 statistics students. Okay, so now let's learn what it is y on x. So now our target is to derive b by x. So the regression coefficient is denoted with what? B by x. So b by x equals to r into, here we are having y, so that's why standard deviation of y by standard deviation of x. So we have to derive this formula. Okay, so for that, first what we have to do is we have to consider the variables. Okay, so let us suppose that xi comma yi for all I equals to 1 2 and so on up to n are bivariate in the sense what? Whenever we deal with two variables, it is called as bivariate. Here x and y we are dealing, no, so that's why we have to consider bivariate variables. Okay, then the regression line y on x is nothing but y equals to a plus bx. So first we have to consider the regression line, that is nothing but y equals to a plus bx. Here we are having what? So where here x equals to what? Independent variable. Okay, x is what? Independent variable. Okay, that means what? Whatever we want, we can substitute x value. But this y value is entirely depend on these variables a, b and x. So that's why this y is called as what? Dependent variable. Dependent variable. Okay, so next a comma b are unknown constants, or simply we can say that constants. Okay, unknown constants or unknown values. Okay, so in order to find out these unknown constants, what we have to do is we have to apply method of least squares. Okay, so these unknown constants, that means what? A and b values, these unknown constants are obtained by the method of least squares. Okay, so by the method of least squares. So what is the formula? What is the principle of method of least square? That is nothing but the sum of squares. We are having two principles, you can apply anything. The sum of squares of deviation between observed and expected should be minimum. Okay, so what? Observed expected value should be what? Minimum. So that's why we have to make this equation to 0. Why? Because minimum we have considered, no? So that's why. So that is nothing but E equals to summation I equals to 1 to n yi minus a minus bxi whole square equals to what? 0. Why? Because here see, sum of squares of deviation between observed value in the sense this one, expected value in the sense this one. Okay, observed and expected should be minimum. Squares they said, no, so sum in the sense summation, square in the sense square, deviation in the sense what? Subtraction. Okay, so now differentiate the above equation. Partial differentiate the above equation with respect to what? With respect to A and B. So that what we get? Dou E by dou A equals to 0, comma, dou E by dou B equals to 0. Okay, now we have to differentiate with A. Okay, so that implies dou E by dou A equals to dou by dou A of E in the sense what? Summation I equals to 1 to n yi minus a minus bxi whole square equals to what? 0. So now if we consider this whole term as x, so we are having here what? X square. So the differentiation for x square is nothing but 2 into x to the power of 2 minus 1. Okay, so 2 summation I equals to 1 to n yi minus a minus bxi whole to the power of 2 minus 1. With respect to a, we are doing no. So the coefficient of a is nothing but what? 1 minus 1 equals to 0. So now this 2 into minus 1 is nothing but minus 2. So if we transfer the 2 from LHS to RHS, it becomes what? 0. So summation I equals to 1 to n yi minus a minus bxi whole to the power of 2 minus 1 is nothing but 1. So that equals to 0. So now we have to multiple this summation with whole term. So summation I equals to 1 to n yi minus, this is constant now, we have to right outside of the summation. So a summation I equals to 1 to n 1 minus b summation I equals to 1 to n xi equals to 0. So these are having negative terms now. So that's why from LHS to RHS we have to take them. So summation I equals to 1 to n yi equals to a summation I equals to 1 to n 1 plus b summation I equals to 1 to n xi. Okay, here we are having what? N value we have to substitute n times. So that's why here simply we can write na. Okay, so plus b summation I equals to 1 to n xi. So summation I equals to 1 to n yi equals to what? Summation equals to na plus b summation xi. Okay, so we have to consider this as equation 2. This is nothing but equation 1 we can consider. Okay, this is equation 2. Again what we have to do? We have to differentiate with respect to what? B. So dou E by dou B equals to 0. That implies dou by dou B. So E in the sense nothing but the same term we have to keep. Okay, here E. So summation I equals to 1 to n yi minus a minus bxi whole square equals to 0. So again we have to consider it as a x term. So it is in the form of x square. Nothing but the derivation is 2 into x to the power of 2 minus 1. So 2 summation I equals to 1 to n yi minus a minus bxi whole to the power of 2 minus 1 into, with respect to b we are doing now. So b coefficient is nothing but minus xi equals to what? 0. So now this minus this 2 only we have to take from LHS to RHS. You please don't take this x1 also. You please don't take, only constants we have to take from LHS to RHS and make it as a 0. Variables we should not. Why? Because with the help of variables only we are going to find out. So then why we have to make them as a 0? So that's why we should not make them as a 0. Only constants we have to make them as a 0. Okay. So summation I equals to 1 to n yi minus a minus bxi whole to the power of 2 minus 1 is nothing but 1 into what? Xi equals to what? 0. Okay, now we have to multiple this xi with whole the term, this summation and xi. So summation I equals to 1 to n xi yi minus a is constant. So a summation I equals to 1 to n xi. Okay, minus b again constant. So summation I equals to 1 to n xi into xi is nothing but xi square, that equals to what? 0. So these both are what? Negative terms. We have to make it as a positive terms by taking from LHS to RHS. So summation I equals to 1 to n xi yi equals to a summation I equals to 1 to n xi plus b summation I equals to 1 to n xi square. So this is what? Equation 3. Okay. Equation 3. So now what we have to do is, now equation, now we have to consider equation 1 as, now equation 1. Equation 1 is nothing but, you can consider this one or else this one. Okay, now or else here you can keep star. Okay, now consider the star equation as, sorry, now equation star can be written as, y bar equals to a plus b x bar. Okay, so why we have to consider star equation like this means the line is passing through x bar and y bar points. So that's why we have to consider equation, we have to consider that those are passing from x bar and y bar. So now multiple with x bar. Okay, so now what we have to do is we have to multiple with x bar this equation. So at that time what it comes, what it becomes? Nothing but x bar y bar equals to ax bar plus bx bar whole square. Okay, so this is nothing but equation 4. Okay, this is equation 4. Now what we have to do is, now this, for equation 4 we have to multiple. Okay, so this is equation 4 now, isn't it? 1 minute. Yes, this is 3 and this is 4. Now what we have to do is, now multiple equation, what is this equation? This 3, equation 3 with 1 by n. Now multiple equation 3 with 1 by n. So that is nothing but 1 by n summation xi yi equals to 1 by n. See, this is equation 3, xi yi. So xi yi, 1 by n I have multiple. Next is a summation xi, next is b summation xi square. 1 by n we have to multiple. Okay, so 1 by n a summation I equals to 1 to n xi plus 1 by n b summation I equals to 1 to n xi square. Okay, so we all know that. Now what we have to do is we have to replace the values if we know any values. So if we are getting any idea related to these formulas, we have to substitute those values. So I got one idea, that is nothing but, so here we all know that covariance of x comma y formula is nothing but, covariance of x comma y formula is 1 by n summation xy minus x bar y bar, isn't it? So now what we want here, this value, that means this value we want. So this value I am taking from RHS to LHS. So at the time what it becomes, covariance of x comma y plus x bar y bar equals to 1 by n summation x5. So I am going to replace in this place these values. Okay, that is nothing but covariance of x comma y plus x bar y bar equals to here a into 1 by n summation xi is nothing but x bar plus here b into 1 by n summation xi square, 1 by n summation xi square. So we all know that standard deviation formula sigma square x, that means variance formula, we all know that 1 by n summation xi square minus x bar square. So now what we want here, this value we want, so that's why here we have to take from RHS to LHS. So that is nothing but standard deviation, variance of x. That means sigma square x plus x bar square equals to 1 by n summation xi square. Okay, so that means what, in this place I am going to replace these two values. So covariance of x comma y plus x bar y bar equals to a x bar plus b into variance of x plus x bar square. Okay, so ax bar plus b sigma square x plus b x bar square. B I have multiple. Okay, this is nothing but covariance of x comma y plus x bar y bar. Okay, so now what we have to do is here x bar y bar, equation 4 we are having the value of x bar and y bar. So we have to replace equation 4. Okay, so equation 4. So covariance of x comma y plus x bar y bar value, how much we have to keep? A x bar plus b x bar square. Okay, so a x bar plus b x bar square equals to a x bar plus b sigma square x plus b x bar square. So ax bar gets cancelled, bx bar square gets cancelled. So the left term is covariance of x comma y equals to b of sigma square x. So now covariance of x comma y is nothing but, we all know that uh, r equals to covariance of x comma y by standard deviation of x into standard deviation of y. Now covariance place we can substitute r into standard deviation of x into standard deviation of y, isn't it? So in place of this I am going to substitute this r into standard deviation of x into standard deviation of y equals to b sigma square x. So here 1 sigma square x gets cancelled. So the remaining term is r equals to here r into sigma y, r into sigma y equals to b into sigma x we are having. So now we want what, coefficient, no? So that's why b equals to r into sigma y by sigma x. So this is sigma y by sigma x. Now here what we can keep, byx equals to r into sigma y by sigma x. So this is the formula for coefficient of regression of y on x. Okay na? So regression coefficient y on x formula is this one. Okay na? So this is the derivation of regression coefficient. Okay, so hope you all understand this derivation. So definitely you will get one question. So either it may be y on x or x on y. Okay, so in the next video I'll explain you x on y. Okay, this is very easy ma. So x and y is nothing but in place of x we have to keep y, in place of y we have to keep x. If we know this one, automatically we can do x on y derivation also. Okay, so please don't forget to like, share and also subscribe. Take care children. Bye. All the best for your exams.